Hi guys, this is the video for chapter 4, lesson 5. Before we get started with our video here, I wanted to spend some time reviewing the things that we've learned in this chapter. So this chapter's focus is really looking at two triangles and how to prove that they are congruent. So we learned a few reasons of how we could narrow down two triangles to be congruent. And so I'm writing a few of them up here, but we've got the these three postulates: CP, CTC, side, 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 and side, angle, side. So let's review a little bit of what these are talking about. CP-CTC is basically saying that two triangles can be proven congruent when all three sides and all three angles are congruent. So if I'm looking at this, all three sides that are corresponding and congruent makes the entire triangle congruent. So I'm marking all these parts. That's like 6 pieces of information to prove these two triangles to be congruent, right? All right, how about side, side, side? So let's say we've got our two triangles. We want to prove that they're congruent. And so side, side, side basically says if two triangles have 3 corresponding and congruent sides, now these two triangles aren't perfect drawings, so they're not really congruent, but if on my information that I can come up with, all 3 sides are congruent and corresponding, then these triangles would be congruent. Then finally, we have the side, angle, side. And that is saying that if I have a side, an angle, and then another side, so consecutively looking a side, an angle, and a side, so your angles sandwiched between 2 corresponding and congruent sides, then these two triangles could be explained to be congruent there. We learned one more theorem. It's called the third angles theorem. This one doesn't describe triangles to be congruent. It describes that the third angle would be congruent if and only if 2 angles are corresponding and congruent. So if I had these 2 angles being corresponding and congruent, then I can now conclude the third angle would be congruent there. Okay, so that is basically, those are basically the things that we've learned so far related to our triangles. So today we're going to learn another postulate. This one's called the angle, side, angle postulate. This is really saying that if I have 2 equal sides, so let's say I have a side here and then a side here, and I'm going to move this over, and both of these sides on this triangle, like basically completes, has the same angle measurement. So let's say I have another same angle measurement, kind of like that, where maybe this would be 45, no, maybe 50 degrees. I wish I could actually measure this. This would be 50 degrees, and maybe this would be 45 degrees. And then these also, we've got 50 degrees, and then we'd say 45 degrees here. If these angles, so I'm just gonna fill in this angle here. This is all the information I need to know these two triangles are congruent. And so if I look at this, what I have is an angle, the 2 green angles, and then this orange side in between. So this is kind of reversed from the last theorem we looked at, the side, angle, side. This is the angle, side, angle, which is saying the side is kind of in between 2 consecutive angles. So let's say I extend this out, and then I extend this out, okay? They would have to meet, they would have to cross at a vertex that basically makes these two triangles and these other sides also congruent. So if I like had a ruler and I measured out this side and I measured out this side and I measured out that angle, I would find that these sides, where these two sides meet, make these two triangles congruent. So we've got an angle and then a side and then an angle. So this theorem says if you have two triangles where the two angles are corresponding and congruent, that and then the side in between those two angles are also corresponding and congruent, then your triangles will be congruent. So hopefully you could kind of see that. On that drawing there. But let's take a look at your study guide now, and let's use this postulate to prove our triangles to be congruent. So if we're looking at our example here, I'm not going to take a bunch of time to go over this one because you can read through it and look at how they came up with the reasons. But one thing I wanted to look at is you've got a given that says there's parallel lines, and then you've got a given here that says CBD. So CBD, I'm going to mark it on my drawing. So every time you see some information, mark it on your drawing. And ADB are congruent, and then it says that AB is parallel to CD. Now we're trying to prove these two triangles to be congruent. So big hint here is you're going to use the angle side angle because that's the one we just learned. So to keep it simple, we're going to use the angle side angle. Now, anytime you see parallel lines, remember immediately we should be coming up with a hypothetical conclusion that it's either going to be alternate interior angles, alternate exterior angles, or corresponding angles to prove, because really the reason they're giving us parallel lines is because they want to have us explain some type of angle relationship. And so to keep it simple, anytime we're given parallel lines, we're probably going to have two parallel lines and a transversal, and we're going to name some type of angle relationship that uses this type of drawing or information there. So if we look at our information, we've got AB and CD being parallel. My drawings are terrible here, but we've got AB and CD being parallel, and then it says it says there's these other angles that are congruent. So if I wanted to use the angle side angle, basically one angle is given to me, I can mark this off, check, that one's done. So I'm looking for a side and an angle. Now if I'm looking for a side, this side is shared by both triangles. So the easiest way, rather than trying to go for these two sides or these two sides, use this one, the reflexive property, right? BD equals BD, and they both share the same side of BD. Both these triangles share it. So now if I'm looking at this, I've got an angle, a side, and I'm missing another angle. The angle has to be sandwiched around this side. So it really has to be this one right here. And so I need to come up with a reason to prove that these two angles are the same. And so conveniently, I know that these are parallel lines. I've got a transversal. So if I've got a transversal with my parallel lines, then really I have a set of alternate interior angles right there. And that's really nice for me. So as we can see, alternate interior angles prove that ABD and BDC are congruent, and then they did use the reflexive property. And so once we have that, we can check this off. I've got an angle, a side, and then another angle right here, ASA, right? The ASA postulate. So there I go. That is done. I can prove those to be congruent. So now looking at this, write a two-column proof. So given this information, let's just mark our drawing. S and V are congruent. So angle S and angle V. Okay, if we're still using the angle side angle postulate, then we can either, use this side or this side, but then we're gonna have to have another angle another angle that's basically on the other side of my side. So my sides are sandwiched between two angles. So let's take a look at our next given. T is the midpoint of SV. So looking at this, T is the midpoint. Remember, anytime you see the word midpoint, you should be able to come up with a conclusion that basically tells you that the two segments separated by the midpoint should be congruent. So let's at least start off our two-column proof. Angle S is congruent to angle V. And then we can say T is I'm going to say MP for midpoint, but you guys spell it all out. of SV, and that's given here. Okay, then we know because this is a midpoint, I can now conclude these two parts should be the same. SV is cut by T into two equal parts. So now I'm going to say ST is congruent to VT, and that's because of the definition of midpoint. Definition of midpoint. Now I need one more angle, and I really have no choice. It has to be this angle for me to fulfill the angle side angle, because angle side angle. See, if I put an angle here, if I prove this angle R and U to be congruent, then I'd have angle angle side, and that's not the postulate we just learned. So is there a way we can prove these two angles to be congruent? What kind of angles are these? I would say they're vertical, wouldn't you? So RTS is congruent to UTV, and that's because of the definition of vertical angles. All right, if I look at this, I've got angle, side, angle. I'm done. So I can now say these triangles RTS is congruent to triangle UTV because of this angle, side, angle postulate. And I'm good, check. Okay, looking at this one, remember we don't need to do paragraph proofs. We can do it as a 2-column proof. So let's draw our givens on there, and then also state our information down. So CD bisects AE and AB. All right, this is interesting. If you have a bisector cutting through sides, then, or sorry, this is, there's a comma here. So it's CD bisects AE. So anytime you have a bisector cutting through another segment, we know it also, a bisector means it splits that segment into two equal parts. So CD is right here. This is the one doing the cutting, and AE is being cut. And so AE is split into two equal parts, being AC and CE. So that's something that I'm going to conclude based off of my given. So let me put that down. Bisects AE. That's given. And then I'm now going to say AC is congruent to CE. So that's because of the definition of a segment bisector. It's cutting a segment, so it's a segment bisector. If it was cutting an angle, it would be an angle bisector. All right, now we've got, parallel lines. So remember, anytime we have parallel lines, we're probably going to use one of our special angles. So I'm just going to put them on the side as hypothetical solutions or statements. So let's look at this. AB is parallel to DC, which means if I had a bisector cutting through both and creating an angle that's on my triangle, I would say this would be the best bisector to use to really show that maybe these two sides are the same. Does that make sense? My drawing's kind of messy, but so I could now say that these two maybe would be congruent because AB and CD are parallel, and then AE is the bisector, and so it makes these two parts being congruent. So I would say angle, I could just call it angle A. Probably angle A is congruent to angle C because of, I need to state my given first before I do this. So let's say that they're parallel. Let's put that on there. AB is parallel to CD. That's given. And now, because of our given information, I'm going to say angle A is congruent to angle C because of corresponding angles. They're in the same spot. So I'm going to say corresponding angles are congruent. If you just say corresponding angles, I'll probably give you the points just because I understand what you're talking about there, and you've labeled the correct angle relationship. And then finally, we have angle E is congruent to BCA. Well, that's right here. So here I have angle, side, angle. Okay, I think I'm done because I've gotten to one of those postulates that helps me prove these triangles to be congruent. So it's angle, side, angle, postulate. All right. Okay, moving on. Let's take a look at our next part. So looking at the back, we're going to learn one more postulate. This postulate is called the angle side. And so what that is saying here is if I have two triangles, there's two consecutive angles that are congruent, and then a third side that's not sandwiched, or another side that's not sandwiched between the two angles, then these two triangles would also be congruent. And so this is what we call the angle side postulate. And I actually have a pretty cool video that I want to show you guys that basically clarifies and goes through these two theorems and explains how not to mix them up. And it has a pretty good visual too. So it kind of reviews the angle side angle for you and then talks about the angle side.
Hey everyone, and welcome to this short lesson where we're going to compare the angle side angle and angle side triangle congruence theorems. So we can start with a quick recap of the angle side angle theorem. If two triangles are congruent by angle side angle, then we have a congruent angle as well as a congruent side and another congruent angle in both triangles. Now again, notice that for angle side angle, the side is in between, in the middle of the two angles. And now by completing the triangle using those two angles, we can see why the angle side angle theorem would prove that two triangles are congruent. Now for the angle side triangle congruence theorem, we still have two angles and one side. It's just the order that's going to change. So in both triangles, we have one congruent angle, and then another congruent angle, and then our congruent side is after those two consecutive angles here. So you have two angles in a row, and then a side next to them. And so now by completing this triangle, we can see why the angle side theorem proves that two triangles are congruent. Now, since these two theorems are so similar, it's a very common mistake for students to mix them up. Both theorems contain two congruent angles as well as one congruent side. Angle side angle has two congruent angles with the side in between those angles, just like it's written, the S is in between the two A's. Angle side has two congruent angles, but in this case they are consecutive and the side comes after them. So we have two congruent angles in a row and then a side. So take a second to visualize this so you don't confuse these two theorems. Again, they both have two angles and one side, but it's the location of the side that will help you to determine which theorem to use.
All right. So that is a good little video that describes the difference between the two theorems or postulates, and hopefully that will avoid the confusion between the two because they are kind of similar but also a little bit different. So let's carry on. Let's do these proofs on our study guide. And what we're going to do here is take a look at the information, and the goal now is to use angle side to prove our triangles to be congruent. So that maybe is a little big hint to know what direction we need to go here. So anytime we see parallel lines, immediately you should be thinking, okay, is it alternate interior, alternate exterior, or consecutive angles. So looking at this, I've got these two BC and EF being congruent. I only have one transversal that cuts through both parallel lines. So as I'm thinking through, I'm guessing that I might have two corresponding angles and they're congruent here. I'm just guessing, I'm not sure, okay? Let's look at our next piece of information. AB is equal to ED. So we've got this segment being equal to ED. And then we have another angle. Angle C is congruent to angle F. So if I was using that piece of information using the parallel lines and assuming my corresponding angles were congruent, then if I look at my information here, I would have angle, angle, side. So I think that's a good direction to go. So let me now fill in my proof. And you guys can totally do that where you're looking at your givens, you're coming up with reasons, marking it on your triangle, and then seeing if that pans out as one of the postulates that prove triangles to be congruent. So, and as you check, you realize, okay, that doesn't really work, then maybe go on to another way to conclude a reason, okay? So BC and EF are parallel, and I'm gonna now say that angle ABC is congruent to angle DEF because corresponding angles are congruent, okay? And then I'm gonna put my other statements. AB is equal to ED, and so that's given. And if you wanna be more specific and say AB is congruent to ED, then we can say the definition of congruency, because if something's equal, it has to be congruent. If you don't have this step, I probably won't count you off because it is a little bit redundant, and I do understand that you know that those are equal. Okay, so then this is another given, and I think I have everything I need, angle, angle, side. So I'm gonna now state that my triangles ABD is congruent to triangle DEF because of angle, angle, side postulate. There it is. So the only new piece of information we had to state was that these angles right here, corresponding angles, were congruent. All right, next one. It says write a flow proof. I will not test you over a flow proof, but I will do this one as a flow proof just to show you how to do it. Basically, how you do a flow proof is, it's kind of like a flow chart here, but you put the information down and then you give the reason on the bottom. So it's kind of like a flow chart, but I'd say, okay, angle S is congruent to angle U, so that's drawn for me. And then I have TR bisects, and I might say like TR bisects angle STU, and that is another piece of given. And so these are both given. Anyway, this now leads to me saying that STR and UTR are congruent because of a definition of a bisector, of an angle bisector. So I'm going to say STR is congruent to angle UTR. That's my statement. And the reason is because of the definition of an angle bisector. Okay, and I'm going to kind of bring this given in also. Now I'm going to flow this over, and I'm going to say now that RT is congruent to RT because both these triangles share that side. So anytime you see triangles sharing that side, you're going to probably use it, reflexive property. And then now I think I have angle, angle, side. Would you agree? I have angle, angle, side, two consecutive angles, and then a side here that's congruent. So I'm going to say these triangles. Oh, it says SRT is congruent to URT. So let me prove that these triangles are congruent first. So triangle SRT is congruent to triangle URT. Now be careful. When I was reading this proof, I didn't really notice that this says angle, but when you see that we're trying to prove the angle, that means this is not our goal. This is not, proving the triangles to be congruent is not the end goal. So I'm going to prove this saying angle, angle, side postulate. And now, if I know two triangles to be congruent, then I know their parts are going to be congruent, right? So if I know two triangles to be congruent, then their corresponding sides have to be congruent. So I can now say that these angles have to be congruent because of CPCTC. Corresponding parts of congruent triangles are congruent, right? So if I have two congruent triangles, then I know their parts are going to be congruent. And then I'm done. So that's my end statement. So this is just one way to do your proof. It's a flow proof, very similar to a two-column proof, except for your statements are in these little bubbles, and then your reasons are just listed right underneath, and then each reason and statement leads into the other statement and reason, and then resulting on your proof that you've gotten. All right, that's it. Before I get off here, I want to show you that this is going to be your homework for this week, is really to make this flip book and also fill out these proofs. On your test, you will be tested over one or two of these proofs. So if you do your homework, you do it right, you know these proofs, I'm going to pick one or two proofs out of here to test you on. So you'll at least be familiar with what the proofs are because you've done them.